Hello, my name is Alex Gilio. I represent vehicle number 13 from Harvard University. Our vehicle, Crimson Cash, is a recumbent tricycle designed with a chromoly steel frame. Its notable features include a rear suspension that allows the vehicle to be disassembled and checked as baggage on a commercial flight, an adjustable boom for the front pedals, and a protective bar extending from between the rider's legs to over their head. While we did not have the opportunity to finish fabricating the vehicle, we made large strides toward completion and were on pace to finish the vehicle before we were told to evacuate campus. We fabricated the front portion of the frame with the exception of the overhead roll bar. Our goal was to ensure that all riders would fit inside the fabricated frame before welding on the roll bar. Our welding fixture used a combination of laser-cut medium-density fiberboard and 3D printed plastics. Here is the finished jig before welding. To determine the best locations for seat mounting points, we 3D printed seat mounting plates that could be clamped onto the frame tubes. We made a similar fiberboard jig for the rear triangle, which also required a number of machined parts for fixturing. The rear suspension pivot, for example, required 5 machined parts in total to achieve the desired level of precision for the bearings. About half the steering components were finished, including the tie rod and the handlebar stems. The compound angled holes on the stems were made using a 3D printed fixture that held the stems at the correct angle relative to the drilling axis. We performed extensive testing on carbon fiber fabrication processes for our seat. To ensure that epoxy resin would not melt the insulation-grade polystyrene foam that we planned to use in our composite construction, we tested a number of surface treatments, such as latex and polyurethane. Our tests showed that no surface treatment was necessary. We then made beams with a carbon fiber and foam sandwich construction. The factors we varied were numbers of layers of carbon fiber and thickness of foam. We tested impact resistance with a hammer and static load strength by standing on the cantilevered beams. The results of our experiments suggested that 3 layers of carbon fiber on each side of 1-inch thick foam met our requirements for strength and stiffness. Additional testing was in progress to determine whether wooden inserts could be embedded into the foam for bolting onto the frame. Balsa wood was chosen for its light weight and because, unlike metal, it would not galvanically corrode with the carbon fiber. While we were not able to perform safety testing on a finished vehicle, we planned to confirm our simulation results for the structural integrity of the roll protection system by using a Smith press machine loaded to provide 2,670 newtons of downward force. A big thanks to the HPVC team for continuing this competition despite current events.